Hello grade 8 and welcome to another mathematics lesson under the topic of geometry of 3D objects. Please note that this actually focuses on 2D objects. Okay, we're going to be dealing with regular polygons. Here we go. Now the important information that you need to know is that a regular polygon is a polygon with all interior angles being equal as well as all sides being equal. Okay, so the first regular polygon is an equilateral triangle, because remember, in an equilateral triangle all three sides are equal and all three angles are equal. Now when you're calculating the sum of the interior angles of a polygon, you use the formula angles is equal to 180 degrees times open bracket n minus 2 close bracket, where n is the number of sides of the polygon. If you are asked to calculate the size of each interior angle of a regular polygon, you use the formula angle is equal to 180 degrees times open bracket n minus 2 close bracket all divided by n, where n is the number of sides. So please remember the following prefixes. For 1, it's mono or uni. For 2, it's di or bi. For 3, it's tri. Please note that a triangle may sometimes be called a trigon. For 4, it's quadri or tetra. So quadrilaterals may sometimes be called tetragons. For 5, it's penta. For 6, it's hexa. For 7, it's hepta or septa. For 8, it's octa. For 9, it's nona. For 10, it's deca. 11 is ondeca. 12 is dodeca. 20 is icosa. 100 is hectare. 1000 is kilo. Please note that 1 million is mega. 1 billion is giga. 1 trillion is tera. Okay. Now when you're asked to calculate the perimeter of a regular polygon, use the formula P is equal to n times s, where n is the number of sides of the polygon and s is the length of the known side. Please take this down. I modified them from seavola.com. So number 1 asks, what do we call polygons that have all sides equal and all interior angles equal? Remember I said they are called regular polygons. Okay, I hope that's clear enough. Number 2 asks, is a rhombus a regular polygon? The answer is no. And the reason being, a rhombus may have all sides being equal, but the interior angles are not all equal in a rhombus. Remember, it's two pairs of opposite angles are equal, opposite interior angles. Number 3 states, what do we call a regular triangle? Remember I said a regular triangle is called an equilateral triangle. Number 4 asks, what do we call a regular quadrilateral? A regular quadrilateral is called a square. Okay. Number 5 states, calculate the perimeter of the following polygons. Roman numeral number 1, an equilateral triangle with a known side of 2 meters. An equilateral triangle has how many sides? 3, right? And the length of the known side is 2 meters. So remember, perimeter is NS, which is 3 and then 2 meters. Okay. 3 times 2 is 6. So the perimeter is 6 meters. Okay, I hope that is clear. Roman numeral number 2 states, a square with a known side of 3 centimeters. So as usual, perimeter is NS. A square has 4 sides. Length of the known side is 3 centimeters. Four times 3 is 12. So the perimeter is 12 centimeters. Roman numeral number 3. A regular pentagon with a known side of 4 millimeters. Pentagon has how many sides? 5. Length of the known side is 4 millimeters. Five times 4 is 20. So the perimeter is 20 millimeters. Roman numeral number 4 states, a regular hexagon with a known side of 6 kilometers. So the perimeter is going to be number of sides, hexagon 6, known side is 6 kilometers. Six times 6 is 36. Roman numeral number 5. A regular heptagon with a known side of 8 meters. Heptagon 7 sides. Length of the known side is 8 meters. So 7 times 8, 56. Perimeter is 56 meters. Okay. Roman numeral number 6. A regular octagon with a known side of 9 kilometers. How many sides does an octagon have? 8. What is the length of the known side? It's 9 kilometers. Eight times 9 is 72, so the perimeter is 72 kilometers. Okay. Roman numeral number 7. A regular nonagon with a known side of 10 millimeters. Nonagon, 9 sides. Length of the known side is 10 millimeters. 9 times 10 is 90. So the perimeter is 90 millimeters. Please don't forget units. Roman numeral number 8. A regular decagon with a known side of 12 centimeters. Decagon, number of sides is 10. Length of the known side is 12 centimeters. 10 times 12 is 120 units centimeters. Okay. Roman numeral number 9. A regular decagon with a known side of 13 meters. On decagon, number of sides is 11. Length of the known side is 13 meters. (11 times 13 is 143. So the perimeter is 143 meters. Roman numeral number 10. A regular decagon with a known side of 17 kilometers. A regular dodecagon with a known side of 17 kilometers. Dodeca, 12. Known side is 17 kilometers. So the perimeter is 204 kilometers. Okay. Roman numeral number 11. A regular hectagon with a known side of 19 millimeters. Okay. Hectare, number of sides is 100. Length of known side 19 millimeters. So the perimeter is 19 times 100 is 1900, 1900 millimeters. You can say 1,9 meters, or you can say 190 centimeters. Okay, but since it didn't specify the units, we leave it like that. Number 6 states, complete the following table. Column A, we have shape, we have those shapes: equilateral triangle, square, regular pentagon, regular hexagon, regular heptagon, regular octagon, regular nonagon, regular decagon. And then we have sum of the interior angles, then we have size of each interior angle. Okay, remember the formula for the sum of the interior angles is 180 degrees n. For equilateral triangle, it's 3 minus 1. So it's 180 degrees. Bone mass, 3 minus 1 is 2. So the sum of the interior, oh, it's actually 3 minus 2, so n minus 2, sorry. So here it becomes 1, my mistake. So it's 180 degrees, my mistake, right? The formula is just this, divided by the number of sides. So it's the size of each interior angle is going to be 180 degrees over 3. So it's 60 degrees, right? So the sum of the interior angles of a square is 180 degrees. N is 4 minus 2, which is going to be 180 degrees. 4 minus 2 is 2. 180 degrees times 2 is 360 degrees. Size of each interior angle in a square is 360 degrees divided by the number of sides, which is 4. It's 90 degrees. Okay. For a regular pentagon, the sum of the interior angles is 180 degrees times n, which is 5 minus 2, which is 180 degrees. 5 minus 2 is 3, which is 540 degrees. Now the sum of the size of each interior angle is 540 degrees divided by 5, so 108 degrees. Okay, for a regular hexagon, the sum of the interior angles is 180 degrees, and hexa is 6 minus 2. So it's going to be 180 degrees. 6 minus 2 is 4. So 720 degrees. Right? So the size of each interior angle of a regular hexagon is 720 degrees divided by 6, and I get 120 degrees. Regular heptagon, sum of the interior angles is 180 degrees. Hept 7 minus 2, so it's going to be 180 degrees. 7 minus 2 is 5. 900 degrees, right? The size of each interior angle is going to be 900 degrees divided by 7, and I get 128,571,428 recurring, right? So the two decimal places is going to be 128,57 degrees. I hope that is clear enough. Regular octagon, sum of the interior angles is going to be 180 degrees. Oct 8 minus 2, which is going to be 180 degrees. 8 minus 2 is 6. So it's 1080 degrees. Right? Now the size of each interior angle of a regular octagon is going to be 1080 degrees divided by 835 degrees. Okay, I hope that's clear enough. Regular nonagon is going to be 180 degrees. Nona 9 minus 2, so it's going to be 180 degrees times 7, which is 1260 degrees. So the size of each interior angle of a regular nonagon is going to be 1260 degrees divided by 9. It's going to be 140 degrees. And finally, for now, the sum of the interior angles of a regular decagon is going to be 180 degrees. Deca 10 minus 2, 180 degrees. 10 minus 2 is 8. So it's 1440 degrees. Okay, right. Now the size of each interior angle of a regular decagon is going to be 1440 degrees divided by 10, and we get 144 degrees. Okay, I hope that is clear enough, and I hope that wasn't too challenging. Okay, it's just the use of knowing how to use the formula and substituting, right, using BODMAS. Okay, if you found this video helpful in any way, please click the like button and subscribe for more content. I hope to see you again, and thank you very much.